Welcome to the Global Engineering Site channel. Today, we're exploring one of the most essential and often overlooked components in any piping system, industrial valves. In this video, we'll focus on three of the most commonly used valve types in heavy industries. Gate valve, globe valve, ball valve. You'll learn their functions, working principles, advantages and disadvantages, and where they are typically used. From oil and gas pipelines to power plants, refineries, and chemical facilities. Whether you're a piping engineer, mechanical supervisor, or just starting your career in the industrial field, this video will help you understand how these valves work and why choosing the right one is so important. So let's dive in and get started. Let's now look at how a gate valve works using this diagram. On the left side, the valve is closed. You can see the gate is fully lowered, blocking the flow inside the pipeline. On the right side, the valve is open. The gate has moved upwards, allowing full unobstructed flow. The hand wheel at the top is manually turned to raise or lower the stem. This stem is connected to the gate, so turning the wheel moves the gate vertically. You'll also notice the bonnet, which houses the stem and connects to the valve body. The yoke supports the rising stem, and the packing gland seals the stem to prevent leakage. This is why gate valves are ideal for on-off service. They create very little pressure drop when fully open. But remember, gate valves should not be used for throttling, as partially open gates can get damaged due to fluid erosion. Here's what an actual gate valve looks like in the field, commonly used in water and oil pipelines. Let's take a closer look at how a globe valve works and understand its internal components. On screen, we see a 3D cutaway view and a sectional drawing of a typical globe valve. At the top, we start with the hand wheel. This is manually rotated to move the stem up or down. Just below the hand wheel, we have the yoke sleeve and gland flange, which support the stem and allow it to move smoothly. The gland eye bolts and gland flange help in compressing the packing, ensuring a tight seal around the stem, preventing any leakage during operation. The bonnet bolts secure the bonnet to the valve body. The bonnet acts as the upper cover and houses the stem and internal components. Now, the stem is a key component. It connects the hand wheel to the disc inside the valve. As the hand wheel turns, the stem moves the disc vertically toward or away from the seat ring. This vertical motion allows precise control of flow, which makes globe valves perfect for throttling service. The seat ring provides a sealing surface for the disc. When the disc rests on the seat, flow is shut off. When lifted, the flow resumes, and you can control how much fluid passes through. The back seat, present inside the bonnet, gives a secondary seal when the valve is fully open, allowing safe maintenance of packing without shutting down the system. In summary, globe valves are designed for accurate flow regulation, and each part plays a critical role in ensuring tight shutoff and smooth throttling control. They may be bulkier and more expensive than gate valves, but they offer precision, reliability, and are widely used in cooling water, chemical injection, and fuel oil systems. Let's now take a closer look at the ball valve, one of the most commonly used valves for quick shutoff applications. On screen, we see a 3D cutaway and a technical cross-sectional drawing of a typical industrial ball valve. At the center of the valve is the ball, a solid sphere with a hole bored through it. When the hole is aligned with the pipeline, fluid can flow freely. When the ball is rotated 90 degrees, the hole is blocked and the flow stops completely. This simple quarter-turn mechanism allows fast on-off operation with minimal pressure drop. The stem connects the ball to the actuator or manual lever. Turning the handle rotates the stem, which rotates the ball inside the body. Around the stem, you'll find packing material, which seals the stem and prevents leakage during operation. The seat is a soft or metal ring placed on both sides of the ball. It provides a tight seal when the valve is closed, ensuring zero leakage. The body of the valve holds all these components together and is usually made of stainless steel, carbon steel, or other alloys, depending on the service conditions. This design gives the ball valve its key advantages: fast operation, low pressure drop, tight sealing, especially in gas and liquid pipelines. However, ball valves are not suitable for throttling. If kept partially open, the high-velocity flow can damage the seats over time. You'll find ball valves widely used in oil and gas pipelines, emergency shutdown systems, ESDVs, gas distribution lines, utility service connections. To summarize, ball valves are robust, compact, and easy to operate, making them ideal for on-off service where speed and reliability are essential. If this helped you understand valve types and applications, don't forget to like, subscribe, and share with your team. Thanks for watching. See you in the next one.